Hi, Honors Chem students. I'm going to go over how to solve a limiting reactant problem, a limiting reactant mass-mass problem. So this is example 1 from yesterday's video, except that it uses grams instead of moles. So first of all, let's balance this equation. You can probably balance this in your sleep now, 1, 3, 2. And notice that instead of given moles, we are now given grams, okay? And again, for part C, now we're being asked for grams of NH3, not moles of NH3. Now, before we go on and do this problem, we're going to just emphasize right now that the BCA table works for moles only, okay, or particles, but we're not dealing with particles right now, okay? Our BCA tables will be filled in with moles because these numbers in the balance reaction represent the ratio for moles or particles, okay? These are the mole ratios, the ratio for moles. So we have to put moles in our BCA table, okay? So let's see how this plays out. All right, so here's our reaction again. So part B says if 35 grams of N2 are reacted with 12 grams of hydrogen, what is the limiting and what is the excess reactant? Show your work. All right, so the first step, step 1, okay, is to convert to moles, okay, right? We've got to convert to moles because we need to put our moles into our BCA table and fill that out. So step 1, we're going to change our 35 grams of N2. Recall that to convert to moles, we're going to divide by the molar mass, okay, by our grams per mole. For N2, right, our molar mass is going to be 2 times the molar mass of nitrogen, which is 14.01. So we get 28.02 grams per mole for N2. So let me divide that. 0.02 grams per mole. Okay, and when we divide that out, we get 1.25 moles of N2. Okay, so there's our moles of N2. Okay, next thing is our 12 grams of hydrogen. We also have to convert that. So 12 grams of hydrogen. Okay, our molar mass for hydrogen, let me do it over here. So 2 times 1.01 equals 2.02 grams per mole. That's our H2. So let's put that down here. Oh, do that correctly. 2.02 grams per mole. Again, divide this out. So 12 divided by 2.02 is going to give us 5.94 moles of H2. All right, so now we want to figure out which thing is the limiting reactant. Okay, so here's our next step. Okay, before we can go on to our BCA table and fill it out, right? This question asks us to identify which thing is excess and which thing is the limiting reactant, right? We can't fill in the BCA table correctly unless we know which of these is going to limit our reaction. So if we look here, 1 mole of nitrogen reacts with 3 moles of hydrogen. So if I take my 1.25 moles of nitrogen, I take 1.25 moles of N2, and I figure out, okay, how much H2 is needed, okay? So if I figure out how much H2 is needed for the 1.25 moles of N2, I can compare to this number and figure out which thing is my limiting reactant. So I'm going to multiply this by my ratio here, right? 3H2 over 1 N2, right? I'm going to get 3 times as much. that would be 3.75 moles of H2. I compare over here. Well, look at that. I've got plenty of H2, right? I only need 3.75 moles of H2, but and I have 5.94. So this is my excess reactant, and this is my limiting reactant. Okay, so there we go. We can say that N2 is limiting, and my H2 is my excess reactant. All right, so we have figured out our limiting reactant and our excess reactant. Okay, so we've answered part B here. Okay, so now what do we do? Now we've got to figure out how many grams of NH3 are produced. So we have to use a BCA table for this. Now remember, the BCA table is in terms of moles. All right, so let's set up our table. We need our balanced reaction, so 1 and 2, okay, plus 3H2. Going to make this table nice and large, so I have plenty of space to write. 2NH3. Okay, so let me divide this up. Here's my before, my change, my after. Okay, put in some nice lines here. Okay, so here's my BCA table. Remember, BCA table has to be in moles only. So let's go up, go back and look, right? We found the moles in part B. So we can take our moles from part B and put them into the table. So here we have our 1.25 moles of N2. Okay, for our H2, we have 5.94 moles of H2. This is our excess. Let me use a different color here to indicate that, right? This is our excess. This is our limiting reactant. Okay, this is 0 to begin with. All right, so look at the question. It asks for grams of NH3. So we do not need to find out anything about the excess, right? I don't see more questions asking me how much of the excess is left over, how much of the excess reacted. So we can just cross this out, okay, and not worry about it, okay? We only need to worry about what we need to find and our limiting reactant, because our change, right, the amounts that react are based off of the limiting reactant. So first of all, right, for our BCA table, by the way, this is step 2 in our mass problems, okay, the BCA table. Our limiting reactant, just as always, we just get rid of it, okay? Get rid of it, get 0. Okay, so that's easy to deal with. But the important part is this change from the limiting reactant, right? This is 1.25 moles of N2. From this change in the limiting reactant, okay, from this limiting reactant amount, we are going to figure out the moles of NH3 from our reactant that reacted away, our limiting reactant. Remember, our change for our NH3 is going to be positive here. These are getting subtracted. So we start off always, okay, let me divide this up a bit. To figure out the moles of ammonia, right, we start off by basing it on the limiting reactant change. So here, I'm going to write down first the limiting reactant change, and then figure out what is the amount of ammonia I can get from the 1.25 moles of N2. Well, again, use the mole ratios, right? I'm going to need to find ammonia, so that goes on top, 2NH3. Okay, the thing that I'm going from goes on the bottom, 1 and 2. Okay, So 2 to 1 is the same as 2. You can see that this is equal to plus 1.25 times 2, which is plus 2.5 moles of NH3, right? Okay, that canceled out. We have moles of NH3 left. So 0 plus 2.5 is equal to 2.5 moles of NH3. All right, so we've got the moles of NH3. Great. Oh, but we've got one more step to do. We've got to find the grams of NH3. Okay, if we were asked for the moles of NH3, we'd be all done. But since we're not, there is a step 3. Okay, so step 3 is to convert the moles to grams. And we do this by multiplying by the molar mass. Okay, so we got to multiply by the grams per mole. That is a multiply. Sorry for my messy handwriting. All right, so we take our moles of NH3, 2.50 moles, and we convert this to grams by multiplying by the grams per mole. Let me find the molar mass of NH3 over here. So we've got 1 nitrogen, that's 14.1, okay, grams per mole. We've got 3 hydrogens, so 3 times 1.01. And I can add this up. This will give me 17.04 grams per mole. All right, so I can just multiply this by 17.04 grams per mole. Okay, I'm going to plug that into my calculator, 2.5 times 17.04, and I get 42.6 grams of NH3. Let's check. Is that what I needed to find? Yes. So let me box this and indicate that that is my answer for part C. Okay, so in summary, what do? We balance the equation. We figure out the limiting reactant, but in order to figure this out, we first need to convert to moles and use the mole ratios to figure out how much hydrogen we needed to react all of the nitrogen. And we found that it was less than the amount that we actually had. So our hydrogen was in excess, our nitrogen was the limiting reactant. Then in part C, it asked for the grams of NH3. So we had to use a BCA table with our moles that we found in part B. And we found that we had 2.5 moles of NH3 produced. So then in step 3, we convert that 2.5 moles to grams using the molar mass of NH3. All right, if you have any questions, make sure you ask in class or email me.